Yes. So today's topic is time and work. All right. So time and work is similar to time, speed, distance. We can say just for a quick comparison. Okay. Uh, there it is. Uh, Speed into time equals distance. Here, efficiency times time equals total work done. Total work done. Okay. So now, if we have to compare, we can compare speed with efficiency. We can, time and time similar, and distance you can compare with total work done. Okay. So this is the basic relativity that you can do initially. But still, as I told you in the previous session, this is similar to the percentage topic that I taught you. Okay, all these topics, it depends only on ratios, proportions, and variation. Okay, like now, if I have to compare, okay, now efficiency into time equals total work done. How does it relate? Okay, how efficiency times time equal total work done. Now, say for example, uh, now we have a bowl of biryani. Okay, now the capacity of the bowl is 100 spoons of biryani. Okay, 100 spoons of biryani. Okay, so that's the amount of biryani in that bowl. Okay, now a person has an efficiency of eating 2 spoons a minute. Okay, 2 spoons per minute. Okay, so how much time does he take to complete 100 spoons of biryani? So obviously, what we do, if 2 spoons 1 minute, 100 spoons, how many minutes? Okay. Now, what is constant here? Okay. Now, efficiency is constant. So, efficiency is what? 2 spoons per minute. Okay. So, since the total work that is to be done is increased, time taken to complete the work also increases proportionately. Now, what is the ratio here? 2 and 100. 1 is to 50. So, I have to multiply this by 50. It will take 50 minutes. 50 minutes to complete 100 spoons of biryani, or else you could have done it like 100 spoons upon 2 spoons per minute. 100 spoons upon 2 spoons per minute. Spoons will get cancelled and minute goes to the units place. So 100 by 2, you get 50 minutes. Okay, so that is what we have to understand here. Here, 2 spoons per minute, you can call it as the efficiency of the person or the speed of the person at which he is doing the work. Okay, so that's why speed and efficiency are compared. And here, since we are talking about the work that is being done, instead of distance, we say it is total work done. Okay, till this, are we clear, guys? Till this, are we clear? Understood why efficiency into time equals total work done?
Yes, sir.
Yeah. Okay, so now let me take you through the next thing. Right. Yeah. Fine. So now when efficiency is constant, efficiency, let me put it as E, when efficiency is constant, uh, time and total work done, TWD, are directly proportional or directly proportional. Uh, more the time, more the work done when efficiency is constant. Okay, I eat 2 spoons of biryani in a minute. If I increased my time to 30 minutes, I would have eaten 60 spoons of biryani. So when efficiency is constant, time and total work done are directly proportional, which means if time is in the ratio A is to B, if time is in the ratio A is to B, total work done will be in the ratio 1 by A is to 1 by B, which is nothing but B is to A. B is to A. You just take the LCM of the denominators, it becomes AB, and multiply the ratio. Okay, so it becomes B is to A. All right. So likewise, when time is constant, efficiency and total work done are directly proportional. Directly proportional, which means if efficiency is in the ratio A is to B, total work done will be in the ratio A is to B. Sorry, I made a mistake. Since they are directly proportional, ratios will be same. My mistake. So if time is in the ratio A is to B, total work done will also be in the ratio A is to B. Okay. Now, so efficiency and total work done are directly proportional. If efficiency is A is to B, total work done will be in the ratio A is to B. If efficiency is constant, time and total work done are directly proportional. If this is in the ratio A is to B, the other one will be in the ratio A is to B. Then total work done is constant. Total work done is constant. Now, efficiency and time are inversely proportional. Inversely proportional. Inversely proportional, which means if efficiency is in the ratio A is to B, time will be in the ratio 1 by A is to 1 by B. Which is to A. Which is B is to A. Okay. So now this is the relationship between efficiency, time, and total work done. Okay. Till this, are we clear? Are we clear with this?
Yes, sir.
Yes. Now let me take you through the real thing. Now, as far as time and work is concerned, there is no formula that you have to remember. There is only assumptions you have to remember while solving the problem. Okay. Now, when a work is assigned to people, how the work can be accomplished? Okay. So the work can be accomplished by a group of people or an individual correct? So the questions can be framed only in two types. Either a work is accomplished by a group of people or by an individual. Only two types of questions you can expect in time and work. Okay. Now, what are the assumptions you have to make while solving questions of type where the work is accomplished by a group of people? Okay. The first assumption is that all men work with same efficiency. All men work with same efficiency. All men work with same efficiency. Second assumption, every day the men work with same efficiency. So now these are the two assumptions we have to make while you are solving the questions based on group of people accomplishing a work. Okay, now what do I mean by all men work with same efficiency? Now for example, let me put it this way. 5 men can complete a work in 10 days. 5 men can complete a work in 10 days. Okay, so now what is the total work done? What is the total work done? Now, if you refer any other books, okay, they would have given it as 5 men into 10 days equals 5 man days. Okay, equals 5 man days. What do you mean by 5 man days? So 5 men, sorry guys. So 5 men times 10 days gives you 50 man days. Okay, this is what they would have put if you refer any of the books. Okay, now when it is like this, we don't get the concept, or we don't get the crux of what is being happening here. So we are multiplying the number of men and we are multiplying the number of days. How men and days will give me this much amount of work done? Now this is work done because we saw efficiency into time taken equal total work done, but it is saying 50 man days. Okay, so now we don't get a clarity, right? So now what I will reframe this is, now let's understand it in another perspective. Now, as I told you, my first assumption is every man work with same efficiency. Now I assume my the men efficiency is eating 1 chocolate per day. Now this is the efficiency of all the men. I just assume because one is the easy number. Okay, so I assume 1 chocolate per day is the efficiency of the men, and every man work with same efficiency, which means man one can eat 1 chocolate a day. Man two also can eat only 1 chocolate a day, and all the other 3 men will also eat only 1 chocolate a day, so that their efficiency are same. Clear? So now 1 chocolate a day into 5 men for 10 days, they would have eaten how many chocolate? 50 chocolates. What is the work done? Work done is 50 chocolates, which means they have eaten 50 chocolates in total by the end of 10 days. Now this makes a little bit sense. Yes, now this becomes now much more in an understandable fashion. Yes. So now this is what I'm going to assume. First thing, all men work with same efficiency, and second assumption is every day they work with same efficiency, which means on first day they ate how many chocolates? Five chocolates. Second day again 5 chocolates. Third day again 5 chocolates. So their efficiency doesn't vary every day, it is the constant all the 10 days. All right, so this is the two assumption that I have to assume while solving time and work any questions based on group of people. Are we clear with this? Yes, all men work with same efficiency, every day they work with same efficiency. Are we clear with this, guys?
Yes, sir.
Yes. So now let's solve some problems based on this so that you get a better clarity. Now to start with some fun question, I'll put it this way. 10 cats can eat 10 rats in 10 minutes. How long will 5 cats take to eat 5 rats? Can I have some answers for this?
10 minutes.
Yes, perfect. How is that?
Because both the values are equal.
Both the values are equal.
Yeah, the proportion is same, sir. So the total work done will never change.
Okay, so how much time do they consume?
10 minutes.
Yes. So one rat can eat one rat in 10 minutes. So obviously it doesn't matter how many rats. So it will take the same number of minutes. Perfect. Okay. Now, second thing. 7 men working 7 men working 8 hours a day can do a piece of work in 15 days. All right. How long will 21 men working 10 hours a day take to finish the same work? Okay, so what's the answer? Yes, guys. Any answers? Guys, any answers?
4 days, sir.
Okay, so now let's check it. So now every man work with same efficiency. So 7 men eats one chocolate, okay, a day. So now let me take 7. So 7, and this is the efficiency. So 7 chocolates is the efficiency. 7 chocolates, okay. And what is the time taken? Time taken will be 15 into 8. So that is the total time taken. 15 into 8 is the total time taken. Now this is of the form efficiency into time. So now this efficiency into time gives me a total work done. Correct. So now that must be equal to 21 into this time taken. This efficiency into time taken should also give me the same total work done. So I can equate these two. Yes. Now 7 3 times, and this 3 and this 5 times, 5 and this 2 times, and this 2 and this 4 times. Okay, so total work, so T will be equal to what? 4. So T will be equal to what? 4. Okay. So it's just like the multiplication table. 6 into 2 is 12. So 4 into what is 12? That's it. So we have to put 3. Similar type. All right. Cool. Okay. So now let's get into the next one. Now I will slowly increase the level. 4 boys or 6 girls can do a piece of work in 18 days. In 18 days. How long will 2 boys and 9 girls take to complete the same piece of work? Okay. 4 boys or 6 girls can do a piece of work in 18 days. How long will 2 boys and 9 girls take to complete the same piece of work? Yes. Yes, yes. So got any answer? Guys, some response? Should I solve it?
Sir, 9 days, sir.
Okay, let's check. Uh, Now here, efficiency of the boys and girls are same. How many boys and how many girls efficiency are same? 4 boys efficiency and 6 girls efficiency are same. 6 girls efficiency are same because 4 boys efficiency times 18 days gives me the same total work done. 6 girls efficiency and 6 girls efficiency times 18 days is going to give me the same total work done. So I can equate 4 boys equals 6 girls. So 2 boys will be equal to 3 girls. Now the question is,
Just talking, we have to connect this one and with that one. We can use that one.
this I'm comfortable with.
No expense.
No, it's okay. I'm comfortable.
You complete.
Ah, no, no problem.
Whenever you start and take break,
Okay.
and just tell me, I'll connect this one.
Okay. Sir. Yeah. If I need, I'll go. Sorry, guys. So now 2 boys plus 9 girls. 9 girls, which means instead of 2 boys, I can put 3 girls plus 9 girls. So now this becomes how many girls? 12 girls. Now the question becomes 6 girls can complete a work in how many days? 18 days. Now, so how many girls? 12 girls will complete the work in how many days? That's the question. Now, work is constant, so more the efficiency, less the number of days. So now efficiency is in what ratio? 1 is to 2. So days will be in what ratio? 2 is to 1. So 2 parts is 18, 1 part will be 9. So it will be 9 days. Are we clear? Are we clear?
Yes, sir.
Yes. So the next one. Eight men and 15 women can complete a work in 6 days. Can complete a work in 6 days. 15 men and 18 women can complete the same work in 4 days. 4 days, right? How long would 3 men and 9 women takes to complete the same work? Takes to complete the same work. Okay. So now 8 men and 15 women can complete the work in 6 days. 15 men and 18 women can complete the work in 4 days. So how long will it take for 3 men and 9 women to complete the work? Yes, got the answer. Shall I solve? Some response?
Yes, sir.
So now here, again, let's get back to that efficiency into time, that formula. Now here, efficiency will be my number of men. So now my number of men is what? 8 men plus 15 women times 6 days gives me the total work done, which means efficiency of men plus efficiency of women together is this efficiency. 8 men plus 15 women is the total efficiency of men and women times the 6 days gives me total work done. Likewise, 15 men plus 18 women, their total efficiency times 4 days gives me the total work done. So I can equate these two. Right. So now what will happen? This becomes this if you cross it, this becomes 3. This becomes 2. Right. Okay. So now this becomes 24 men plus 45 women equals 30 men plus 36 women. So now we can just equate it. So it would be equal to 9 women equals 6 men. 9 women equals 6 men. Okay. Now let's take the second one. This one. Okay, now let's take this one. 15 men and 18 women. Now I can convert that to 15 men plus 18 women. I can take it as 9 women. I know it is 6 men. So 18 women I can take it as 12 men. I can take it as 12 men. So that will be equal to 27 men. So 27 men can complete a work in how many days? 4 days. Okay, now 27 men can complete a work in how many days? 4 days. Now this I got. Now the question is 3 men and 9 women. So 3 men and 9 women, I can consider it as, instead of 9 women, I can take it as 6 men. Correct. So they become 9 men. So now the question becomes 27 men can complete a work in 4 days. So 9 men will take how many days to complete the work? Lesser the efficiency, more the time taken to complete the same work. So now this is in what ratio? 3:1. 3:1 ratio. Right. So this should be in what ratio? 1:3. 1:3. So 1:3 means 12 days. If one part is 4, 3 parts will be 12. Are we clear with this or not? Are we clear? Are we clear? Are we clear, guys?
Yes, sir.
Okay. Now, so this is the basics of group of men working together. Okay. Now let me take you through the basics of individual person accomplishing a work. Now here, when I consider individuals, the difference between group of men assumptions and individual men assumption is only one thing is broken here. which is every man work with same efficiency. That assumption is taken, and only one assumption is I deal with individuals. It's every day they work with same efficiency. Every day the individual work with same efficiency. Work with same efficiency. Which means now a person A can complete a work in 10 days. Which means every day he completes 10% of the work. Meaning 100% of the work, 100% in 10 days. So in one day, how many? 10% of the work. Simple. Okay. Now B can complete 100% of the work in 15 days. Now B will complete how many? So 100% in 15 days. Now if you remember the fraction table, what is 1 by 15? It's 6.6. So 6.6 bar. I cannot put bar here. So 6.6% in one day. Okay. So now B completes 6.6% of the work every day. So B is having the efficiency same every day until 15 days. A has the efficiency of completing 10% of the work every day until 10 days. Okay, so now this is the basic assumption. So now A plus B can complete the work in how many days? Now we know A is 10%, B is 6.6%. So together they will do 16.6% of the work in a day. 16.6% of the work in a day. If 16.6% in one day, then in 100, so 100% of the work in how many days? It will be 6 days. Because 1 by 6 is, in fraction table if you remember, 1 by 6 is 16.6. 1 by 6 is 16.6 percentage. So 100 percentage should be 6 upon 6. 6 upon 6. So 16.6 into 6 should give me 100 percentage. So that's why it is 6 days. That's why it is 6 days. So this is one way of solving time and work. We can, if you know that, if you are really good at fraction table, you can, put it directly like this, and you can finish it off. It won't take much time. Don't go for unitary method, that method, this method. Don't go with fractions only. But anyways, you should know that in some cases it will be helpful. Now, by the unitary method, what is unitary method? Nothing big difference. So I am assuming instead of 100%, instead of assuming the total work done to be 100%, what is the ratio? 1:1. I'm now going to consider as 1. 100% is what? 1. 100 upon 100. 1. So instead of considering, in previous case I considered 100%, that's why I got 10% every day, that's why I got 6.6% every day. Now I am considering it to be 1. Okay, so which means A eats 1 chocolate in 10 days. Let me put it that way. So every day he will eat 0.1 chocolate, which is nothing but 1 upon 10 or not, 0.1 chocolate. And B will eat 1 upon 15 chocolates, 1 upon 15 chocolates, which is 0.6666. Correct. So 15 chocolate. Now what you will do? Now you add up the fraction and you have to take the LCM. LCM is 30. So the numerator will be 3 plus 2 upon 30. 3 plus 2 upon 30 is nothing but 5 upon 30, which is nothing but 1 upon 6. Now, in a day, what is their efficiency? Efficiency is they complete 1/6 of the chocolate. 1/6 of the chocolate. Now, 1/5 of the chocolate they eat in a day. 1/6 of the chocolate they eat in a day. Times efficiency into time we should do or not. Now, this should be equal to what? 1. Efficiency into time should be equal to 1 because we consider total work done here as 1. So, now the question becomes 1/6 multiplied by what number will give you 1? Or you can consider this as efficiency is in the ratio 1:6, time will be in the ratio 6:1. So 1/6 you should multiply by 6 to get 1. That's it. This is what they call it as unitary method. Okay, so in some sessions, if they are, if they had taught you this, if you got 1/6, then the inverse of this will be the time taken. They would have stopped it till there. They will not tell you why the inverse of this gives you that time. Okay, so now this is the unitary method. Now the third method, this is what very efficient and you can apply it anytime. Predominantly I prefer you to go with this third method. Now the third method is now efficiency of A times 10 days gives me total work done. Likewise, efficiency of B times 15 days gives me total work done or not? Total work done or not? Now what do we get here? I taught you this while taking number system. X times 10 equals Y times 15. What concept is this? This is the concept of LCM. This is the concept of LCM. Which means total work done here, it is a multiple of 15 as well as it is a multiple of 10. Okay, it is evident here, correct? Total work done is a multiple of 15 as well as it is a multiple of 10. So what is the minimum number which satisfies 30? 30 is the LCM. This 30 is what you got in the denominator when you added up the fraction. So I will say the total work done is 30 chocolates. 30 chocolates. Now you can get the respective efficiencies. Now what will be A's efficiency? 3 chocolates a day. This is what you got on the numerator. Now what will be B's efficiency? 2 chocolate a day. Right. So we got the efficiency of A, we got the efficiency of B. Now A and B together will eat what? 5 chocolates a day. If they eat 5 chocolates a day, shit. Sorry guys. So there is something. Sorry guys. Yeah. So now if they eat 5 chocolates a day, in how many days they will complete 30 chocolates? 30 upon 5. Which is 6 days. Which is 6 days. Now this third method will help you a lot. Okay, so you should be good at calculating LCM. Okay, but this third method will help you a lot. Okay, so now, so this is just the basic of individuals. Now let me do a basic question. And one more thing, maybe like I will put this. Now A and B, took up the task. A and B took up the task, and they are paid um, 500 rupees. Okay, they are paid 500 rupees. What is the payment of A? What is the payment of B? Okay, always remember, nobody will pay you for the number of days you work. They will pay you for the amount of work you have done. Amount of work you have done. So the amount of work done depends on the efficiency of the individual as well as the number of days he works. Okay, so now total work done ratio of an individuals will be the share ratio. Okay, so now here um, they complete the work in 6 days. What is their efficiency? Efficiency is in the ratio 2:3. Okay, so now here A and B work for same number of days. A also work for six days. B also works for 6 days. So now it doesn't matter if we multiply the number of days and to calculate how many work they have done and to find the ratio, because 6 is going to be anyways a multiplying thing with their efficiency. 6 into 2, 6 into 3. Okay, we can neglect the 6. So here their payment ratio or share ratio will be equal to the ratio of their efficiencies. So 200 will be given to A and 300 will be paid to B. Okay, so always remember this. Okay. Now yes, solve this. Rita can do some work alone at 75% efficiency, 75% efficiency in 40 days. Okay. Now, Mita can do the same work, in 40 days if she works at 125% efficiency. Okay. Um, Find the number of days they will take complete the work together. Yes, solve this. Find the number of days they will take to complete the work together.
Should we calculate for the 100% efficiency, sir?
Yes, 100. Yeah. If they work at full efficiency, if they work at together at if they work at 100% of their efficiency. Yes, correct.
So 38 days.
Okay, let's check it. Um, so now Rita can do some percentage of work. Okay. So Rita can complete 100% of the work in 30 days or not? If she works at full percent efficiency, correct? Because if efficiency is 75 and 100, 3 is to 4 is the ratio, then 4 is to 3 should be the ratio of completion of days. So Rita can complete in 30 days. So this girl can complete in 50 days, correct or not? 50 days. So what will be the thing? So 150 chocolates, 150 chocolates. So what is the efficiency of uh, Rita? It will be 5 chocolates a day, 5 chocolates a day, and she will eat 3 chocolates a day. 3 chocolates a day or not? Yes, 3 chocolates a day. Correct. So what is the total number of chocolates? 150 chocolates.
Mita's efficiency must be 48 days, right, sir? That is less, 20% less.
Okay, once again. So now efficiency, this is in the ratio 5. See, 125 and 100, what is the ratio? 5 is to 4. So it should be in the ratio 4 is to 5 or not? I'll put it here. 125%, if at 125% 40 days, then 100% how many days? Correct. So these two should be inversely proportional. So this is 5 is to 4. 25 5s are 25 4s are. So this should be in the ratio 4 is to 5 or not? So 50 days. Clear?
Yes, sir.
Yeah. So yeah. So it is just 150 by 8. 150 by 8. So it will be what? 18.75 days. 18.75 days. Are we clear with this? Are we clear? Guys, are we clear? Shall we proceed to the next?
Yes, sir.
So now try solving this. From now on, it will be a little bit moderate to tough. Okay. So now Alok and Bimal can do a piece of work in 24 days together. Alok and Bimal together can do a piece of work in 24 days. Now, Bimal and Chandra can do the same work, together in 30 days, right? So now Alok alone started the work. Alok alone started the work and quit after 8 days. And quit after 8 days. Quit after 8 days. Now, then Bimal took up the work. Took up the work. Bimal took up the work and worked for 18 days alone. Worked for 18 days alone. And then quit. And then quit. Okay, he worked for 18 days alone and then quit. Okay. Finally, Chandra completed the remaining work. Finally, Chandra completed the remaining work. Finally, Chandra completed the remaining work in 30 days. 30 days. Now the question is, how long will Chandra alone takes to complete the entire work? Entire work. Now this is the question. Now this is the question. Solve it. Yes, anybody got the answer? Guys, some response?
No, sir, we didn't get.
Okay, shall I solve? Shall I solve?
Yes, sir.
Okay, so now look at this. Now, for these type of questions, the assumptions which I told you plays a very, very important role. Only if you can understand the assumptions, you can solve these type of problems in a much easier way. Okay, now let's take a look. Okay, Alok and Bimal together can, which means A and B together, they can complete 100% of the work in 24 days. 100% of the work in 24 days. A and B together. Okay, and B and C together can complete in how many days? 30 days. 100%. Now, okay. So now, what is given in the question? Alok started the work alone and quit after 8 days. And Bimal, he worked for 18 days. Now what I'm going to do is, this Bimal's 18 days, I'm going to split it as 8 plus 10. Okay, 8 plus 10, because Alok has worked for 8 days. Okay, so now what happens is, now can I say Alok 8 days? Now, Alok and Bimal can complete 100% of the work in 24 days, which means Alok worked alone for 24 days, Bimal working alone for 24 days. When I club it, it becomes 100% of the work. Likewise, Alok working for 8 days and Bimal working for 8 days, they both work for 8 days respectively, which means together they have worked for 8 days, alone individually. By doing this, they will complete 33.3% of the work or not, or 1/3 of the work or not. Because 24, I can write it as 8 plus 8 plus 8. In 8 plus 8 plus 8 days, 100% of the work is completed. So for every 8 days, 1/3 of the work is completed. Now this part is clear? This part is clear or not? Clear or not clear? Okay. Now let me take Bimal's 10 days and Chandra completed the remaining work in 30 days. Okay, now out of the 30 days, I'll take 10 work. So Bimal 10 days, Chandra 10 days. So which means together they work for how many days? 10 days. Together they work for how many days? 10 days. So in 30 days, they complete 100% of the work, which means 10 plus 10 plus 10. So for every 10 days, they would have completed another 33.3% of the work or not. They would have completed another 33.3% of the work. Now, C is having only 20 days left. In that 20 days, the 20 days he completed the remaining 33.3% of the work or not, which means C is capable of doing 1/3 of the work in 20 days. So when he will complete 3/3 of the work, 3/3 of the work he will complete in how many days? 60 days or not? That's it. Are we clear? So C alone can complete the work in 60 days. Are we clear with this question? Yes or not? Guys, some response? Naveen, Shekhar, Akash. Preeti, have you understood?
No, sir.
Which part you didn't understand?
That how you divided that 8 plus 8 plus 8, that's top one.
A and B together, they complete the work in 24 days or not?
Yes.
24 days, I can split it as 8 plus 8 plus 8 days or not?
Huh.
Yeah. So for every 8 days, they will be completing 1/3 of the work or not?
Hmm.
Yeah. So that's what Alok worked alone for 8 days. Bimal worked alone for 8 days. So together, they would have worked for 8 days or not? So they would
Yes.
have completed 33.3% of the work.
Huh.
Likewise, now Bimal has now left out with 10 more days,
10 days.
and C worked for 30 days, and from 30 days I take 10 days. So now I can rewrite it as B and C worked for 10 days together or not.
Hmm.
So 30 days I can rewrite it as 10 plus
10,
10
10.
plus 10.
Hmm.
So for every 10 days they complete 33.3% of the work.
Hmm.
So how many percentage of the total work is done? 66.6% of the work is done.
Hmm.
Now C has to work alone. Now C will complete the remaining work in how many days? 20 days or not?
20 days. Hmm.
So C completes 1/3 of the work in 20 days. So 3/3 of the work he will complete in how many days? 60 days.
60 days.
Got it?
Yes, sir.
Yes. Now try to do this. He can complete a work in 6 days. We can complete a work in 12 days. A and B started working. Together. A left after 3 days. A left after 3 days. B continued for 2 more days and quit. A completed the remaining work. What is the share of A and B if they had agreed for rupees 7,200 as payment. What is the share of A and B? They had agreed for 7,200 as their payment. It's an easy one. Yes. Have you got the answer? This. Anybody got the answer? Or should I solve? Some response? Naveen, are you there? Naveen, are you there? So now, see this one. We need not, we know every day they work with same efficiency. Okay, and we pay for the amount of work one has done. Correct. Now here we don't know for how many days A has done the work. Correct. Okay. But we know B alone worked for 3 plus 2, 5 days. And what is the percentage of work he would have done? 5 upon 12. Because 100% he can complete in 12 days. So 5 days he has worked. This would be the percentage of work he would have done. So his share would be 5 upon 12 into 7,200, which is 3,000. 3,000. So this will be the share of B. And what will be A share? 4,200. 4,200. That's it. All right. So this is the importance of understanding the assumptions in time and work. So once that is understood rightly, we can, do the question much faster and simpler way. All right. So with this, I end the session, guys. All right. So I'm done for today. We shall continue the other topics in next classes.